All right, so this is an example of proving that an equation is an identity. So as you recall, when we prove, we do not use properties of equality by going across an equal sign. This is the way it shows up in your textbook, but I would suggest doing something like this, where you kind of put a line, right? You put a line down the middle, and you work on just one side at a time. So that's what we'll do. I'll make a little bit more room for us over here. Pull this over a bit. So we want to make sure, we want to see if we can manipulate this using identities and mathematical manipulations, multiplying, adding, subtracting, multiplying by conjugates, writing in terms of sine and cos, using all of your identities that you've learned about to transform one side into the other. And of course, we want to pick the side that's sort of more complicated because we have more to work with. We can whittle it down. So let's do this one. Now, what's obvious to me is a couple things. We have a multiplication here. You see that? We have a multiplication. So that's a good idea to expand or to perform the indicated operations when you can. The other thing that jumps out to me is that we have, I'm missing a theta. That jumps out to me. But we have a reciprocal identity here, don't we? Okay. So what you might want to do, and again, you want to show as many steps as humanly possible to communicate all your work. So I would change this one first. So let's make this sine theta. What's cosecant theta? That's 1 over what? It is. It's 1 over sine theta. And then, so we want to switch that. So you want to show that you know what cosecant theta is. Then we can do our multiplication. So we multiply this in. We get sine theta over sine theta when we do this multiplication. And this one here, we have minus sine squared theta. Okay. So at this point, we've done two things. We've rewritten using reciprocal identity, and we've done an indicated operation by doing the multiplications. That's great. Now we look at what we have, and we have some choices, right? We could do this subtraction, again, perform an indicated operation. That's a good tip. But what jumps out at me here, and should be jumps out at you, is that sine over sine is just 1. And if you substitute that, this is going to be one of the fairly obvious identities, right? The Pythagorean identity here, one of the forms would be cos squared theta equals 1 minus sine squared theta. So using your identity, the Pythagorean identity, you can see that this actually equals cos squared theta. And when you have the same thing on both sides, you're done, and you can signify that you're done with our fancy quod erat demonstrandum, right? QED, you're done. And that would be the full marks for this question, showing all of your work, indicating how you get from sort of here down to here, and that's that. So any questions about that? So this is the second one for you to try, and many of you have already started that, but why don't you give this one a try and see if you can work it all the way through. Okay, so that's sort of what your work should look like there, very similar to that first example. Any questions? Note that 1 plus tan squared is also a form of that Pythagorean identity from the first section we learned.